This video will be about inequalities and their graphs. So when you're working with an inequality is a situation where multiple answers could work. A real-life example might be the maximum capacity of an elevator. So let's say the maximum capacity is 2,000 pounds. And we want to know, well, how many pounds then could the elevator hold? Well, it could hold 0 pounds, or 1, or 2, or 3, everything up until we hit 2,000. So it's every single value up until 2,000, and we write that using the symbol less than or greater than. So less than 2,000, that's every number smaller than 2,000. So our possible symbols, we have less than, which is just this one. It looks kind of like an L, but that's been turned sideways. We have less than or equal to, which has the line underneath. That means you include the value itself. So where I've written it here, that means the elevator couldn't hold 2,000 pounds itself, just below 2,000 pounds. We have greater than, and we have greater than or equal to. So there's all our possible ways to use inequality symbols, all our possible inequality symbols. So when we have an inequality, we may want to check and see what numbers are actually a solution to this inequality. So if I just gave you a list of numbers, and said, okay, would these work in this inequality? Would they be a solution to the inequality? We're just going to plug them in and check. If I plug in -5 for x, we look at this and say, is this true or not? Is -5 less than 3? That is true, so this is a solution. Let's try the next one. 7 less than 3. Is 7 less than 3? That is not true. That is not a solution. Plug in 0 for x. Is 0 less than 3? That is true. That is a solution. If on that one I probably should have said false instead of just it does not work. Then we try -2.1. Is -2.1 less than 3? That is true. So that is a solution. So we can plug them in to check to see if they are solutions or not, even if the inequality is a little more complicated. Let's say we have 3 plus 2x greater than or equal to 9. So again, let's check some numbers and see if they work for our inequality. Let's plug in 5. 3 plus 2 times 5 greater than or equal to 9. When you have a number next to a letter, it's assumed to be multiplication. So 2 times 5, order of operations says we do multiplication before addition. So 2 times 5 is 10. 3 plus 10 is 13. So then we check, is 13 greater than or equal to 9? That is true. 5 is a solution. Let's try the next one. 3 plus 2 times -6. 2 times -6 is -12. 3 plus -12 is -9. And -9 is not bigger than 9. That is false. -6 is not an answer. Let's try these last two. 3 plus 2 times 0 greater than or equal to 9. 2 times 0 is 0. 3 plus 0 is 3. 3 is not greater than or equal to 9. So that is false. That one does not work. And our last one, 3 plus 2 times 3 greater than or equal to 9. 2 times 3 is 6. And 3 plus 6 is 9. So this one, 9 greater than or equal to 9, since we have the line underneath, we have the or equal to option. This does work. It is true. So that is a solution. If it had just been greater than only, 9 greater than 9 is false. But if you have the line underneath, it is true. You also have to be careful when you're comparing your negative values. If I compare -5 to -1, since on our number line, -5 is further to the left than -1, -5 is actually smaller. It is less than -1. That seems counterintuitive because we know 5 itself is bigger than 1, but the negative signs make everything opposite of what we expect for our inequalities. So the second thing we can do with our inequalities is draw a graph on our number line. So when we're drawing our graph, we need to know a couple of things. When we draw our inequality graphs, we will sometimes use an open circle, and we will sometimes use a closed circle. If our inequality symbol is a less than or a greater than, then we use an open circle. If it's less than or equal to or greater than or equal to, we use a closed circle. Because again, greater than or equal to is including the value itself. So filled in, we're saying include the point that we're actually on. Whereas if it's an open circle, we say don't include that point. The second thing we're going to have to do is shade. We might shade to the left, we might shade to the right, because again, we're including multiple numbers. There's multiple solutions to our inequalities. So for our shading, if it's less than or equal to, we shade to the left. If it's greater than or equal to, we shade to the right. So let's look at an example. Y less than or equal to -3. So we can draw our number line, mark where 0 is, that's the center of the number line. So we have to decide from this less than or equal to symbol, are we going to have an open or closed circle, and are we going to shade to the left or to the right? So since it is equal to the line underneath, we put a closed circle. And since it is less than, we shade to the left. So that is our graph. We can also write an inequality from the graph itself. If I give you a graph, we can write an inequality from this. We know it's going to be our variable. You can use really any variable. It doesn't have to be x. It is an open circle, so we do not have a line underneath. And we're shading to the right, so it is greater than. X greater than 4 would be our inequality. You do have to watch out for it being in the wrong order. If I said -7 less than y. Before you can graph this, you must put the variable first. Has to go variable first, then you switch the inequality symbol, -7 last. That, if it's not in the correct order, we don't know the correct way to shade, so we do have to put it in the correct order. And notice the wide part of the inequality, the open mouth, is facing to the y both times, and the pointy part is facing to the 7 both times. So the reason we flip the inequality is to keep that same direction, the pointy part towards the 7, open part towards the y. Once it is in the correct order, we can just go graph. I'm going to just mark 0 and the -7. Greater than, open circle, and shading to the right. So that concludes our discussion on inequalities and their graphs.